in the last video, one of the last section wasn't clear, so I'm gonna add this video to make it more clear. So we defined a complex number as a plus ib with ab in R and I squared is -1. Okay, so there is a plane that we can use it to graph the complex numbers. Okay, it's called the argent plane. Okay, so it's like the xy plane. Okay, so we can think of z as having a and b coordinate. Okay, so here, so this is the real, this is the imaginary part. So let's say this is our z. So here we graph, let's say this is a and b, this is our z here. Okay, but we defined something that we call the conjugate as a minus ib. So let's see, this is our z. The conjugate of z is just the symmetric with respect to the to this axis. Okay, so it's gonna have a the same, but b is gonna change. So in this case, z that we call z bar is gonna be a minus ib. Okay, so let's say we have this number 1 plus 2i. So 1 plus 2i, let's say this is 1, this is 2. So this is, let's call this one z1. So z1 is going to be here. So it has real part 1 and the complex part is 2. So this is our z1. Okay, what's its conjugate? Its conjugate is z1 is 1 minus 2i. So it's going to be, it's symmetric with respect to the real part axis, to this axis. Okay, so another thing that we had to do one more time is that what's 1 over z? So 1 over z, it's 1 over, what's z? It's a plus ib. So to make this one clear, we multiply by the conjugate. Okay, top and bottom, on top, on the top and on the bottom. So we get a minus ib over a plus ib times a minus ib. Okay, we're gonna expand this one to make it clear. So we're gonna do this part here using the properties of complex number. So a plus ib times a minus ib is, you distribute and you collect the real terms, and without forgetting the fact that I squared is -1. So here we have a times a is a squared. So a times minus ib is minus iab. ib times a is iba. And the last part is I times minus I, it's minus I squared. Minus I squared is minus 1, which is 1, so we have b squared. So we have b squared. So here we collect the real part with the real parts. So it's a squared plus b squared. But this one here, if you think of it this way here, you get I times ba minus ab. Okay? But what did we say about these terms? So we said that a and b are reals. Okay? And we know that r is commutative. Okay? That means ab is the same as ba. So for instance, 3 times 5 is the same as 5 times 3. Okay, so that's why this one here is 0. So we get only a squared plus b squared. Okay, so let's go back. So here, this part is, we compute this part is a squared plus b squared. So we're gonna have a minus ib over a squared plus b squared. And this is the inverse. The inverse of the complex number, say. So here, so here I think this video is clear. Okay, so let's say I have z is 1 plus I. Okay, what's 1 over z? So from here I see that a is equal to b is equal, a is equal to b is equal to 1. So here we have 1 squared plus 1 squared, which is 2. So I'm applying this property here, and I just need to take the conjugate. Okay, so it's 1 minus I. Okay, so it's gonna be the 1 over z is gonna be like 1 over 2 minus I over 2. Okay, later we're gonna prove that 1 over z is equal to z times z bar. It's like this. It's like we did nothing. We applied the same rule. We multiplied the top and the bottom by the conjugate. But we don't need to worry about this. As we learn this stuff, these ideas and this definition will become very clear and very useful in the long run. Okay, so we define the argand plane as this plane here, where we plot the complex numbers. Okay, so on the x-axis we have the real part, on the y-axis we have the imaginary part, and it's called the argand plane. Okay, or the complex plane, any but this is like forgotten. You see it in like complex books, but let's say the complex plane is better. Okay, anyways, don't forget that I squared is 1 minus 1, and any number, complex number, can be written as z a plus ip. Okay, we're gonna see more complex numbers in the coming section. We're gonna define more what we mean by other definitions, like the norm or the argument of a complex numbers. We're gonna need that to start working with some nice and beautiful stuff. Thank you.